Hello, once again after the break. We are in Wrocław in Kino Nowe Horyzonty for those who are watching us online. And right now we will have a speaker who's here for the 4th time. He's been working in many industries and he asked for a short introduction because we are running out of time. Viktor Kirilov.
Okay, so today we're going to present yet another solution to online identity, which is decentralized. And first, we're going to go over some of the problems with the current web. And the first thing is that it's host-centric, which means that everything happens on with IP, DNS, and unicast communication, which means that all of the links, the URLs which we have, many times they get broken, and either the content is no longer there, or it's a different content. And also the documents which we get from a URL, they're host certified, which means that we need to trust the host that whatever we get is what we were supposed to get. And even the designers of the internet by now agree that they shouldn't have used IP address both as a locator and as an identifier. And also, within 20 years, more than 98% of all of the URLs on the web are broken in one way or another. And effectively, we are experiencing a comprehensive breakdown in the chain of custody of facts in the web, and we're building our history on shifting sands. There's also a lot of centralization on the web. DNS, certificate authorities, Google and search, browsers, cloud providers, data centers, routing. We're also living in the surveillance capitalism right now, where personal data is the most valuable commodity, and trillion-dollar industries are built on top of it. Also, the algorithms which recommend to us content, they're black boxes to us, and they're the ones which determine what goes viral and what ideas surface and what propagates. And currently, the people who write the algorithmic feeds in our social media are perhaps maybe the most powerful people in the world. And for that, you should watch The Social Dilemma from 2 years ago, a documentary. Another problem is with social media and identity, that we think that we have our own social capital, but in reality, the Web 2 platforms, the current platforms, own our reputation and everything. And our identity is centralized and fragmented in just a few large players. And currently, we don't have much choice, because if we want to leave a social network, we're going to lose all of our connections, reputation. We cannot export it. And that's because the network effects of these platforms are too strong. And also, there's no accountability and transparency in how they moderate content or what their algorithms actually do. And there are many other problems. Another problem is the vertical integration of these big companies. And because there is no interoperability between them, that means that we have less innovation, and also that they have to re-implement many times the same things over and over again, because they can't reuse it, because they have to keep their data to themselves, and they can't share it easily. And that means that the effort to solve some of the problems is fractured, and it's done again and again and again in a few big in-house places. And also, they compete for the same set of talent to solve the same problems, instead of, if we could solve some of these problems only once, and all companies could use that. But we're not in that world now. And also, many platforms have APIs, like Twitter, and many ecosystems were built in the past, which were then killed when the platform decided that it's no longer advantageous for them to offer these APIs for third-party clients to develop on them. And also, there's a really hard barrier to entry for new startups, especially if you want to make a new social network. So now we're going to go over some of the building blocks which we're going to use in order to design our solution. And the first thing is the Merkel Tree. I hope that you're familiar with hash functions and public key cryptography. So if we have 4 elements of data, and if we hash them individually, we're going to get 4 hashes. If we then combine these 4 hashes in pairs and hash the hashes in pairs, we're going to get 2 more hashes. And then if we hash those middle-level hashes of this tree again together, we're going to get a top hash. And now, if we change any of the 4 elements at the bottom, their hash will change. And that means that their hash of their hash will change. And that means that that change will trickle up to the tree. And that means that the root hash will no longer be the same. And so if we commit 4 elements with a specific root hash in this tree, and we can later reconstruct this tree for these 4 elements, and if the hash matches the root hash, we can be certain that it's the same 4 elements in the same order. The next thing we're going to discuss is a Merkel Proof, which is basically a way to prove that something was included in a set. And again, we have a Merkel tree where 16 elements were hashed, and then those hashes were hashed together, and that way up to the top. But suppose somebody gave us just the green element, and he didn't want to give us the other 15 elements, but he wanted us to know that this green element was included along 15 other elements in a set which was committed with a Merkel root. All we need to do is, if we have these 4 blue hashes, we can reconstruct the root hash if we have this green element, if we hash it, and then if we hash it with these blue hashes, we can reconstruct the root hash of the tree. And if that matches with the root hash, which we know is the real one, we know that this element was for certain included in this set, and we don't need the other elements in the set to check that. All we need is some other hashes. Next, what is a blockchain? Well, it's basically a hash-linked chain of blocks. And yeah, basically every block contains a hash of the previous block. And also every block contains a bunch of transactions, which are the changes in this new block. And what's the difference between a blockchain and a state? The blockchain is the list of transactions. It's the list of changes, the incremental patches, the diffs. But the thing which is limited there is the block space, how much we can fit inside of a block. And that's because of the distributed consensus between the machines in the internet. And the state is actually the current state of the ledger, which is who owns what. And it is materialized by applying all of the changes from all of the blocks to actually get the current state of the ledger of the world. So the blockchain is the diffs, the state is the actual current state of the current shared database, a state machine. And every blockchain has a state transition function, where it takes the old state, a diff, which is the next block full of n number of transactions, and it computes the new state, which is the new state of the shared database. And also, this state, which is the current representation of who owns what, it can be also Merkelized, and we can construct a Merkel tree out of it and a Merkel proof, and we can include that Merkel proof Merkel root of that tree inside of the blocks, so that the blockchain does not contain the state, but you can construct the state with the blockchain, and also the blockchain, each block contains a Merkel root of the state, which would result if you construct it up to that point. Another thing we're going to discuss is what is content addressing and IPFS. Well, if we hash a file, we're going to get a content hash of that file. And the interplanetary file system is a content addressable peer-to-peer network, where we request the file by the content hash. We just submit a request in the peer-to-peer network, and we get the file later on. And there are no limits to the number of files or their size, but we can have some latency issues. Another thing to note about IPFS is that it is an unincentivized network. That means that just because something has an IPFS address does not mean that you'll be able to retrieve it. Nobody has to store it for you. And that is just like torrents. So here's a problem statement. We have reached local maximum with the web. And how can we use Web3 beyond all the buzz to actually improve social media and the web? And I think that we should start with identity. And I think it is the foundation. And what is actually an identity? It's an identifier and nothing more. And we should follow the Unix philosophy to do just one thing very well. And everything else should be composed and layered on top of it. We shouldn't try to handle everything in this world. So no NFTs, no creator coins, no finance and whatever. And yes, everything else, like profiles, verification, KYC, privacy, all of that can be layered on top of identity. And let's use a blockchain for the property rights for identity. Headjack is going to be our solution, and we're going to combine existing building blocks in designing this system. First design goal will be Webscale. So the web is huge. Within 1 minute, we generate literally hundreds of terabytes of data, or maybe even more. And it's literally enormous. And we should design it for billions of users and for unlimited data. Another design constraint should be Web2-like user experience. What does that mean? It means that we shouldn't ask people to actually deal with public and private keys and for them to sign transactions and interactions. And we also shouldn't expect people to host their own software at home to run it. Like even the most diehard crypto natives, they want to actually use third-party services because it's much easier. And the last thing is that the URIs, which identify content, it should be human readable. It shouldn't be full of hashes or just numbers. There should be names inside of it. And currently, every Web3 solution only has hashes. The third goal should be decentralization. Like, you should be sovereign when it comes to your identity. If you have a key pair, you should be able to own it completely. And the other thing is credible neutrality. So anyone should be able to create an account, create a service, or broadcast through the network. But we should distinguish between speech and reach. Just because you can speak and have your content addressed does not mean that anybody will be processing it and displaying it to others. So content moderation is just another layer on top of this. And also, anybody should be able to run their own software at home, but that will be at a disadvantage because they won't be able to aggregate all of the activity on the web, right? And also, decentralization should be the base layer, and you cannot build something decentralized on top of something centralized. It has to be decentralized, the base layer. And the fourth goal should be simplicity. Like, it should be really clear why and how much it can scale. There shouldn't be, it should be clear. And it should be also really clear what are the guarantees for data availability, for the economics of the system, like when would it break, and also how much time it takes for a transaction to be final. And if we could construct a global singleton that manages all of this scale, that would be the easiest to work with. And the key is to design that singleton. And that would be the easiest mental model for everyone if there was only one blockchain and not a landscape of different chains and bridges between them to actually solve this problem. If we can solve it with a singleton, that would be great. So the first distinction which we're going to make is on-chain versus off-chain. And on-chain, we're going to put the absolute bare minimum, which means account identifiers, which in our case are not going to be even hashes of the public keys. It will be just an auto-incrementable integer. Another thing which we're going to put on chain is the public key ownership. And that's actually optional, because users in our system do not need public keys, but they can, at any point in time, bind keys to their accounts. And also name ownership, like who owns which names. And that, again, is optional. You don't need to own a name in the system, but you should be able to. And also, some of the authorization actions are on-chain, but most will be off-chain, and we'll discuss that later. And the last big thing which will go on-chain is the Merkel roots for off-chain data. And what is off-chain data? Off-chain data is all other events, documents, actions, content, whatever, all of that. And applications where users generate it, applications are going to generate it in big batches, and they're going to submit this content to the chain in a batch. But they're not going to submit the actual data to the chain. They're actually going to construct a Merkel root with all of these events for the latest batch, and they're going to submit only the Merkel root, the hash of the Merkel tree, the top hash, to the chain, and that's called a commitment for the entire blob of data. That's also called anchoring. You anchor the blob of data. And there are going to be three types of accounts. Like the first is normal users, the second is identity managers, and they're going to handle authentication and authorization with applications for users. They're also, so think of this like single sign-on, login with Google. You have your identity manager, and you're going to log into different services, applications, with your IDM. It's going to also handle direct messages for you, and maybe it's going to archive your activity. And we can think of IDMs as custodial because you don't need a key by default, and they're sort of going to own your account. But later, we're going to see why that's not such a big deal. And actually, you can also host your own identity manager at home. And the third player is going to be applications, which are going to be used for browsing and publishing media. And actually, all of these three players are going to have on-chain IDs, and even a single entity can play all three roles. But it's useful to have them separate as a mental model to think about them and the different categories which they will be playing, the different roles. So when users want to view media through applications, they need to authenticate off-chain using their IDM or keys, which means that they can either sign a message or their identity manager can create an access token to the application, but that doesn't have to happen on-chain. That can be just an event in a big blob where it doesn't even have to be anchored to the chain. Another thing which users are going to be doing is they're going to be posting content through applications. So not just reading and logging in, but also posting. And for that, they're going to either authorize the application to post on their behalf without having to have their keys next to them and sign every action explicitly. They might just authorize the app to post on their behalf with no signatures. And that can happen either on-chain with an identity manager, as we will later going to see. And such on-chain authorizations, they're batched together by the identity manager, and they contain only one signature, by the IDM. So you don't have to explicitly, as a user, sign anything. The IDM signs a big bunch of authorizations for maybe 1,000 of its customers. Or another way is off-chain authorization, which is again with an access token, with something like OpenID or zeroauth or something like that. Or if users don't want to authorize an application to post on their behalf, they can explicitly sign content with their keys if they have keys. But that's very cumbersome. And the last thing is that applications, they're going to aggregate content which was generated by all of their users, and they're going to submit it in bulk, as we talked in the previous slide. So again, the content, all of the events, comments, likes, that's off-chain in big batches of data. And only when we construct the Merkel tree and the Merkel root of that tree, only that Merkel root goes on-chain to commit, to anchor all of that data. And so the blockchain will be hidden in the background for users. They won't have to touch it by default. And all of the costs will be covered by IDMs and applications. So what are off-chain messages? Well, that's basically any event, action, data, document, content, whatever a user does with his interactions, that's an off-chain message. And there will be a taxonomy of message types. Like there will be in a hierarchy, and there will be a few base types, and we'll be able to inherit those and create new types. And we should have a fallback presentation for new types. Why? Because initially, every new type is not supported by a bunch of applications. Maybe only one application supports a new message type. But we should be able to introduce new message types in our ecosystem. And if there was a fallback presentation, we will be able to gradually evolve the system and introduce new messages without breaking everything. So suppose we have a prediction message, which is, in this case, a JSON object with a few attributes in this case. And if we had a fallback rendering template which substituted the different attributes in different places in a string, suppose when somebody creates such a message and some other application does not yet support how to visualize it properly with different colors and buttons and whatever, it can just stringify it and show it as a string message. And that still shows that someone else on some other application created this message and he broadcasted this to the world. And if somebody is following him, he should be able to see this activity, even though it's a new message type. So everything is a message. Like every time you follow someone or you become a friend with someone, or all of your account preferences, or all of your content which you generate, that's a message. Also attestations, verified credentials, all of that. And you actually can also have privacy and even group discussions, closed groups with messages, because these messages, they don't have to be unencrypted in these big blobs of data. They can be encrypted in such a way that only a few entities can decrypt them and show them only to specific sets of people. And also, these messages, they don't have to be accessible by the public web. Just because you build a Merkel tree out of a big blob and you post the Merkel root on chain does not mean that that blob of data is accessible. So you can actually use this for intranet for companies. Like you can have internal documents which are using this global identity layer, it's using this global addressing layer and this Merkel root scheme, which we're going to later see how it's used. But still, that doesn't mean that anyone else in the public web will be able to download your data. And so we can actually rebuild any primitive and service from Web 2 with just messages. So what does the content blob actually look like? So first, applications, what do? They collect a bunch of messages from their different users. After that, they group them by user. And in this case, we see that the orange user has 3 messages, 1 post, 1 like, and 1 comment. We also get indexes for the individual elements within each group, starting from 0. And then, when an application decides it's time to commit the next blob of data, it constructs this big blob with all of these event groups with the activity of all of the users which actually did something. And it also creates an offset table, which we can use in order to index within this blob of data. Then it constructs a Merkel tree with all of these events individually hashed, and we construct this Merkel root. And then the only thing which the application posts on chain is the Merkel root definitely, and maybe the IPFS hash of the blob, so others can download it, but that's optional. So what is a nonce? Nonce is, in our case, going to be an on-chain number tied to every account. So when an account, which will be most usually an application, publishes a batch of data with a Merkel root, their nonce is going to be incremented. And the blockchain is going to save the nonce for this account, how it maps to block height, which means in which block did this application submit its third batch of data. And so whenever an application is constructing a batch of data with a bunch of messages, which are comments, likes, whatever, all of them, they will be assigned to the next nonce of the application when this blob is actually published. And this is used so that we can translate the pair of an application ID and a nonce to a block height. And then we can use the block height to actually get the block and actually get the Merkel root to verify all of the content. So how do we address specific elements within a big blob of data which some application has constructed? Well, we have the application ID and the nonce, the first two integers. With them, we can get the block height, from which we can get the block, from which we can get the Merkel root for the entire blob of data. And we can then verify the integrity with the hashes of all of the elements. And then we can use the offset table once we have fetched the blob, and we can actually drill inside of the blob with it, and we can see where is the activity for user 644. And then we can also even ask for the third element, in this case index 2, of that user. So we can actually individually address any element without any limits to how big these elements are or how many they are with just 4 integers, not some hash. And this is what it's going to look like. Like we have a blockchain where the only thing which goes on in the actual blockchain are these commitments, these anchors made by applications for a lot of off-chain data, which is in big blobs. And in these blobs, there are going to be all kinds of elements, and they can evolve, and they can be new kinds of elements, whatever. And they can refer to each other with these URIs, with just 4 integers. Any element can refer to any other element which was already created or is within the current blob of data. So we have effectively constructed a global virtual address space. And accounts which are owned by applications, for example, they can signal on-chain some way to be contacted directly. Like this is my REST or RPC API endpoint. And so we can retrieve data for URI in many different ways. We can either fetch the entire blob from which it was actually committed by tracing which was the block height, and we can request that. We can request the Merkel root and the hash of the blob, and we IPFS hash and then fetch it. Or we can ask the application, because we know what was the application used, because it's part of the URI. It's the first integer. Or we can ask the user or their identity manager, which we can see on-chain, because we also have the user ID inside of the URI of this specific element. Or we can actually ask some archival service for this URI, or we can even use a peer-to-peer network, which is URI-focused. And then we can use a Merkel proof to check the authenticity if whatever we got is actually indeed corresponding to this URI, if the hashes match. So this is basically an infinite virtual address space. And many other protocols, they deal with storage and retrievability of data. But in our case, we only address data. We don't deal with how it's stored and how it's retrieved. We just allow others to do that. And they can even change how that's happening. But the key is that the addressing of the content is permanent. So let's see what our blockchain state looks like. So not the different blocks, but actually the materialized state, which shows who owns what. So first of all, we can see that the different elements in this state, we have constructed a Merkel tree out of that. We have hashed those elements individually, and we have constructed a Merkel root. And now we see that there are name states and there are account states. We have 2 account states here. And the one on the right, we can see it's identity 7, and it has had different public keys which were bound to it at different block ranges. And it also has a nonce mapping. So for nonce 1, it was block 5. For nonce 2, it was block 6. So this is probably an application, because otherwise it wouldn't need nonce, because it has probably anchored off-chain content. This is most likely an application. The other account, it doesn't have public keys, and it only has different block ranges when it had authorized a different account to do actions on its behalf. OK, sorry. But now let's look at the names. One of them is Joe, and we can just see that Joe was owned by different accounts within different block ranges. But the other account name state is Twitter, and we don't see only the owners, but we also see another nonce. But this nonce is a different kind of nonce. This nonce is a name nonce, and it doesn't map to a block number. It maps to an account ID with an account nonce. And now, why is that useful? Because whenever an application which owns a name commits on-chain a bunch of off-chain data in a blob, the name nonce is also going to be incremented, and it's going to be mapped to the account ID and account nonce at that time. So suppose we have this URI, which is no longer with 4 integers, but actually with 2 names and 2 integers. We can actually ask the blockchain to translate the name and the name nonce to an account ID and an account nonce. Then we can ask the blockchain to translate this account ID and account nonce to a block height. We can then ask the blockchain to tell us who owned Johnny at that block height, at that specific point in time in the blockchain. And then now we have the canonical form. So we have effectively translated a human-readable URI to a canonical one with just 4 integers, and still the same thing. And even if the ownership of these names changes in the future, our original URI at the point of publication of that content is still the same. Not still the same, but it can still be translated to the canonical URI. So links are not going to be broken as long as someone still hosts the data somewhere. And this is something which no other system in the world can do. And so instead of having caches full of, URIs full of caches, we can have URIs full of names, and they can be permanent and stable. So let's see what can users do. They can have a public key, and a private key, of course, and they can sign actions explicitly, and they can be completely self-sovereign. But that's very bad user experience, and it's very stressful and risky. They can also have a key, but they could have authorized an identity manager and applications to post on their behalf without requiring signatures, and that's a lot better UX. But they still retain the ultimate control, because if any application posts something on their behalf which wasn't actually posted by them, they can actually revoke the access with the key and even retroactively revoke the access. And also some users might choose not to have a key at all, and they can be created on-chain as an account by an identity manager and be effectively owned by it. But at any point in time, they can graduate to a fully fledged citizen in this ecosystem who has a key and bind it. And so also users will not be thinking about the blockchain transaction costs, and they won't have to think about wallets by default. So here what do we have? We have 3 users, 2 applications, and 1 identity manager. And on the top we have the blockchain and IPFS for the big blobs of data. And so the user on the right, he has a key, and he's signing explicitly his actions when he's using Reddit. And he's also from time to time submitting an on-chain transaction, because he can. But the other ones, the other 2 accounts, one of them has a key, but the other does not. But they both have authorized an identity manager, and they have then used that identity manager to authorize applications to post on their behalf. So whenever they're interacting with Twitter or Reddit, they don't actually have to have their private key loaded in their phone to sign messages. And we see that only Twitter and Reddit, they talk directly to the blockchain and to IPFS. And whenever one of them constructs a big enough blob of data with user activity, they push it to IPFS, and they also upload the Merkel root for all of the elements on the blockchain. So the blockchain is used mostly by applications and identity managers. And what mostly goes on it is Merkel roots, maybe IPFS hashes if we want that data to be retrievable. And identity managers, they just post compressed pairs of integers of who authorized who, and revocations of authorizations, and maybe key pair changes. And so the bulk of the activity on the chain happens by services, not by users. So it's not about being trustless, it's about better trust. We don't want to have to deal with keys every day. I mean, we need familiar user experience, what we actually currently have with the current systems. And this is possible because creation is different from finance. And we can have different trade-offs for a blockchain which is organized around identity and creation. And that means that our off-chain data, it does not need to be available, and we don't need to think about the storage and retrievability of that data in our protocol. We just need to address it. And the retrievability guarantees, they can be on a best effort basis. If an application does not actually make data available, but it should have, it's just a bad application and nobody has lost money. And the other thing is that custodial, meaning that you have authorized someone to post on your behalf, is okay, because again, there is nothing to steal. And the worst thing that can go wrong is that some application posts something on your behalf, but you didn't authorize it. But guess what? That's currently possible right now as well. Like Facebook can post on behalf of a president without them actually doing it. So it's literally the same situation, but a little bit better. So we can actually have self-authenticating documents. So when we fetch a document for a URI with the 4 integers, we can first check that this data was actually really corresponds to this URI, and it was actually included in the block with the Merkel proof. And we can also check if it was indeed created by the user. How? So either the data was explicitly signed by the key of the user, in which case we can ask the blockchain, did this user really own this public key at that point in time? And because the state of the blockchain is in a Merkel tree, we can actually construct a Merkel proof for did this account actually own this public key at this point in time. So we can not just check that if this data was part of a blob, but we can actually check really if it was signed by that user at that time. And if he actually could sign it with this public key, private key. Or if the data is not explicitly signed, but the application was authorized to post on behalf of the user, we can again ask the blockchain state for a Merkel proof for was this application authorized at that point in time to post on behalf of this user. So again, we can check even that. Or if it's not on-chain authorization, it's off-chain with an authorization token. Again, it's going to be embedded in the message, and we're going to be able to cryptographically check it again. And so even if nobody hosts a specific document anymore, if we have cached it locally with the proofs, we can later resurface that document and prove the authenticity of it, even if the application and the user are long gone. So all we're doing is actually ordering integers throughout time on the blockchain. That's the biggest use case for it. And some throughput, some numbers. Suppose we target 100 kilobytes per second of blockchain growth, which is actually very easily achievable with modern technology around Ethereum. Like, it's not going to be Ethereum itself. It's going to be a technology around Ethereum, like a rollup, a scalability solution. And with 100 kilobytes per second, we can support 1,000 applications which anchor a big terabyte blob every 10 seconds. And we can also support 6,000 authorizations per second on-chain, which happen by identity managers, but which maps to around 0.6 authorizations per person if we were 1 billion people per day. But we can actually have unlimited off-chain authorization with access tokens. So we don't have a limit for authorization. This is only if we're using on-chain authorization, which we don't need to use, actually. And also, this is just really naive numbers without any optimizations. And also, we can actually go way beyond 100 kilobytes per second. So we have effectively built a time-stamping machine, a cryptographic sequencer of events, where every authorization event and key and name change is ordered in time. And also, on-chain and off-chain data is batched for efficiency, on-chain by identity managers and off-chain by applications in the big blobs of data. And so we can handle unlimited amounts of off-chain data, literally unlimited. And we can also we have the capacity for billions of identities on-chain. And the URIs, they're permanent, even those with names. And when are names useful? When they're part of a URI, which identifies a resource. Like, who cares if you own a name if the content which you generate is not tied to that name? Like, it's much more useful if it's part of a URI. And also, we can address within documents, because these URIs, they're stable. And if there's a new version of the document, it will have a new URI, which links to the previous one. But again, the old version, if we decide to address a specific paragraph of a post, or maybe some character range or audio range, again, that's going to be permanent. That's going to be stable within that version of the document. And this system can displace actually DNS and certificate authorities globally, because it's a confluence of multiple interrelated things. And it has very strong synergy and network effects. Because if we're just trying to solve names on the blockchain, like Namecoin or Handshake or anything like that, that's clearly not enough. We need multiple interrelated things together. So what we're doing is we are linking data to identity at scale with one chain, which links them, sorts them, proves them, and binds them forever. So what's the difference between a Twitter and a Reddit post? Well, they're both comments in a tree structure. Reddit expands the tree by default, or at least to some degree. Twitter only shows one level of comments. And a Reddit post is always a part of a subreddit. So Twitter is account-focused, Reddit is community-focused. But why don't we merge their state? They don't need to be separate states, and we don't need to have separate identities on these two platforms. And we can have shared reputation between them. And we can just use different UIs for viewing the same set of data. And so whenever I post something on Reddit, there should be something like a Twitter-like feed where people who follow me see my activity on Reddit. If they want to, they should be able to actually opt out of such activity. And same goes for YouTube. Whenever somebody posts a comment on YouTube, if people follow them on another platform, there's no way to know about that new comment. And that shouldn't be the case. That's only because the current status quo promotes monopolistic platforms which silo their data, and there is no interoperability between them. And so whenever identities become portable, that's when backends, applications, they become liquid, and we can actually move from one application to another much easily. And so this is what it means to be data-centric. So the focus is going to be on the data, but the applications, they're ephemeral. They're going to come and go. They're just different ways to view the data and interact with it. But again, the focus is on the data. It's going to be shared by all, because identity is shared by all. And how are applications and infrastructure going to work in this brave new world? So in this case, we have two infrastructure companies. So you can think of them like AWS. Their job is to ingest and store all the data, a lot of heavy lifting. They can filter it by some criteria. The criteria might be different. They can create algorithms and indexes and maintain those. And then what can applications do? They can choose an infrastructure provider, so they don't have to re-implement all of that themselves. And they can even migrate to another one if they want to. They can choose which indexes and what filtration to use for what to show to their users. And they can even let users choose their own algorithms and filters. Like, we can have a lot more choice, and the applications can give us what's available on the infrastructure below. And these applications, like Twitter and Reddit, which if they were implemented in this brave new world, they would be paying for the indexes they're using to the infrastructure company. So infrastructure focuses on the heavy lifting, on extreme optimization, and the applications, they can only focus on actual good user experience and only on what they actually need, which is the UI, or maybe ANT moderation, or they can even use different moderation filters from infrastructure, and they can just pay as they go. If you create a new interface and initially it doesn't have any traffic, and you don't have to pay because you're not making any API calls, but the moment you get a lot of users, you're just gonna start having a lot more API calls and pay for your usage. And you can serve ads. Again, why not? I mean, we're not going to have a world without ads, never, unfortunately. Or they can also charge for users. But currently, Facebook is always ad-free. I'm not sure if they have a subscription model. But in this brave new world, anybody will be able to create a new interface, a new application with a different business model. And they will be able to do it because they don't have to bootstrap their own network effect. So a lot more interoperability, no more silos of data. And just like a compounding interest is really important to finance, the same is true for software. We need composability and accessibility and interoperability for data. And in this brave new world, anything can become a new data stream. Like anytime an account or a word or a URI gets referenced in the public content. And we can also have advanced filtering, and we can transform and join streams however we like, as long as somebody pays for the costs of processing of the data. And anybody should be able to create a new algorithm and a new index for the public data. But currently, you don't have access to Twitter or Facebook's data. You just don't. And when you create a new algorithm or a new index, you can pay a company, an infrastructure company, to what happened?
We lost the feed.
Did it just happen?
Yep.
OK, what do I need to do? OK. And so users, I mean, people who create new indexes, they can pay infrastructure companies to maintain those indexes, and they can even charge applications to use their indexes if they're useful for anyone. And we'll be able to make any type of query which we want. And also, by linking data to identity without keys at scale, we can unbundle a lot of monopolies in decentralized media. We can have a lot more competition, lower barriers to entry, more startups, better search engines, or at least more competition, and a lot more choice for users, because now you will be able to actually leave a social network, but actually take all of your social graph and your identity with you to another different interface, because now applications are going to be just thin layers to present data, and the network effect is going to be shared. And we're going to be able to have composable media, when if you have a new idea, you can literally pick off-the-shelf solutions and code the literally minimal amount of work which you need to do to have something new. We're going to have a lot of redundancy and resilience because of horizontal scaling, because this addressing scheme is so it allows for a lot of topological flexibility. You can change where it's stored and how it's stored, but it's still addressed the same way. And so there are two ways to make money in this world. You either bundle or you unbundle. And in this case, we have unbundled the media stack into different layers, and we're allowing for markets to develop the best solutions possible for different layers of this media stack. And this is something which no company can do by themselves. This is something which only an open ecosystem can do. And Aristotle once said that the whole is greater than the sum of its parts, allegedly. So we can give birth to History 2.0, the ledger of record, where links will no longer be rotting because some host is no longer serving the exact same thing, or they have changed their resource paths because of some reason. And also the documents which we get from a URI, they're going to be self-authenticating because we can actually get the Merkel proofs and prove everything about them and link them to identity. And we can think about this as the global Git, where we'll be able to duplicate all kinds of documents. We'll be able to track all of the changes to documents, and we'll be able to view the different versions of a document or a page or a New York Post or whatever. And we'll be able to rebuild new systems of trust and reputation systems on top of this. And we can finally have argument from cryptography instead of from authority. And there are many other possibilities, like being able to see all of the public activity of someone, no matter from which application or what type of activity. And we'll be able to filter that multidimensionally by including or excluding based on the user or the application, the content type, the tag or keyword or whatever. Currently, you either follow or you unfollow, and that's it. We can have universal bookmarks because currently now these URIs will be permanent and stable. And imagine what kind of knowledge management tools we'll be able to build on top of this new web of permanent URIs. We'll be able to tune our notification settings because notifications are just alarm clocks which someone else is setting on us. Like, we should have control on when we receive the notification settings, but the current platforms, they don't have the incentive to give you those tools to limit your attention and time which you have spent on the platforms. But now we would be able to have new tools which let you do that. And we'll be able to fork communities and moderation filters and UIs if we're not happy with something. We didn't cover a lot of things, and there are a lot. And I want to leave you with one quote: "The medium is the message." Marshall McLuhan, who was a media theorist, once proposed that we should be studying the communication medium itself and not the messages which is carrying. So in this case, we need to take a look how we're, how the current social media platforms are constructed and how they operate. And also, we can think of AGI as artificial global intelligence, where every follow is a synapse in the global metabrain. And recently, Elon Musk said that you can think of Twitter as a collective cybernetic superintelligence, where a lot of billions of interactions are happening per day. And obviously, this is a single company, and it's not optimized for very much for truth or for productive conversation. And that's because it's a company which is trying to make revenue at the end of the day, and nobody has access to their data besides them. And also, the complexity nowadays is extreme in the world. And I think we need to upgrade the complexity of our sense-making to actually match the complexity of the world. And I think that the host-centric model must go, that we're currently in an asymmetric relationship with today's platforms. They have siloed our data, and we're their captives. And we've been given a one-size-fits-all algorithmic feed, which is our information diet for many people. And that's solely optimizing for engagement and time spent, not time well spent. And I think that, we shouldn't settle with what we currently have. And we should be able to surface any kind of signal, and anybody should be able to construct a new algorithm or a new index and let others use it if it's useful. And so what is the metaverse? Well, here's some quotes which we won't have time to read, but I think that the metaverse is going to be built in layers, and the bottom layer is identity. And I think that you should be able to have your activity in one social media linked to your identity, then you should be able to go through another application and have that linked to your identity as well. If you choose, you can actually have multiple identities. And then if you jump to some 3D world by some specific company, again, that should happen with your same identity. Like, the current blockchains cannot handle what they're currently talking about, the metaverse. And I think that we need to build it in layers. And we don't need to add finance and NFTs to everything which we see. And so this is what the internet looked like in 2005. And this is basically the different internet protocol ranges and the routing paths, and they're color-coded depending on the region of the world which they're in, the different continents. And everything on the internet happens host to host. And the internet is the largest engineering project the Earth has ever seen. We're just getting started. And I think that it's time for us to add identity to the OC model of the internet, because the internet is constructed in layers. And if we add a new meta layer of identity and content addressing, we can literally reshape how the big companies function. And I think that identity, the cool thing about it is that it needs to be solved only once. And if we can actually solve it once in the most perfect way, then there is no better set of trade-offs to solve it, then we can rebuild everything else on top of it. And that's the cool thing. Only once. And that's it.
Do you have any questions to Viktor? Please raise your hand if yes. Okay, there are 2 questions, and we have time only for 2 questions. Thank you.
Yes, so I have one question. What is the thing that can convince big companies like Facebook or Twitter to start using your project, start using the decentralized identity project, if they lose control over this part of their application? So this is not good for them. It's good for us, but not for them.
Yes. So none of the big companies would adopt this, at least initially, because it's literally a threat to their business model. But the thing is that if it's obvious enough that this is the right way, and if it's obvious enough for a bunch of entrepreneurs that there's a lot more long-hanging fruit in this ecosystem, if it's a new grassland for them, and if composability between new services can give a lot more value to users, and if that's obvious to people, they're going to want to build on top of this and not on the other platforms. And yes, this system will not be adopted by the big platforms. It's intended to kill all of them. And but the thing is that no single company can give you what this ecosystem could give you, because this is infinite composability and interoperability between platforms. And if it's explained the best possible way that this is indeed the best set of trade-offs, and it's the most realistic way to actually add identity to the internet, and if enough people believe it, I don't know. Like, whenever Ethereum was first built, nobody had any idea what the applications on top of it would be. And there's this saying that if you build it, they will come. And many venture capitalists mock that, because obviously it's not guaranteed that anybody will come if you just build a solution. But sometimes, if the solution is good enough and it enables a lot more innovation on top of it, and if it's communicated right that it is actually the right design, actually people come, even if you don't have a specific strategy. No, you need a strategy, but it's possible.
Okay.
Any other questions?
Yes,
you, yes.
I have a question. What about GDPR and law to be forgotten?
Yes, that's one of the things which we didn't talk about. Yes, well, some things will be different. Like currently in this ecosystem, if you delete a post, you will have created a new message, and that message should be processed by all of the infrastructure companies, and they should remove that element, and they should stop serving it to others. But still, anybody will be able to cache it and save it locally. And it will be a little bit different for GDPR. There might be some bad actors which keep data which should have been deleted. But
Anyway, today. That's true today too.
yeah, but yeah, that's true even today. And even if we cannot cryptographically save things today, we can still screenshot them and post them again and again and harass people. Like online harassment, for example, it's been here forever, and it's probably going to keep happening. And this solution does not make it any much easier. It's practically the same, almost the same.
Okay, thank you. And one little question I have, because you have told that we can link a newer version to old one, but can we link old one to newer?
No. So in order to know that there is a new version, you have to have heard or heard and processed the broadcasted event for the update. But so whenever you're using an application, and that application is aggregating a bunch of messages and it's posting them and anchoring them on the blockchain, that application can then signal to all of the users affected in that, who are participating in that blob, and that application can notify the identity managers of those applications to save this data. And then whenever you're using, whenever you're viewing a specific element, a text post, you can ask the identity manager of the user who created that thing, has there been a newer version? So if identity managers keep track of all of the new events for their users from any application, they will be able to tell you, has there been an update to something?
Okay. Thank you, Viktor, once again. We have a small gift for you.
Okay.
Okay.